Hello everyone, I am Rasika Wakhore from Cummins College of Engineering for Women Nagpur, studying in second year in Electronics and Telecommunication branch. And today in this video I'll explain you about digital multiplexer. So at first we see what is multiplexing. Multiplexing is the technology that is able to combine multiple communication signals together in order for them to transverse and otherwise signal communication medium simultaneously. Multiplexing can be applied to both analog and digital signal. In this section, let us consider the multiplexing of digital signals at different bit rates. The digital multiplexing will enable us to combine many digital signals such as computer outputs, digital voice, digitized facsimiles, and TV signals. Let's see the block diagram. The digital data can be multiplexed by using a bit-by-bit interleaving procedure. This can be achieved by using a selector switch, which is sequentially select a bit from each input and places it over a high-speed transmission line. At the receiving end, the bits received on the common line are separated out and delivered to their respective destination. Let's see the working principle of digital multiplexing. The digital multiplexing is based on the principle of interleaving symbol from two or more digital signals. This is similar to TDM, but it does not require the periodic sampling and waveform preservation. The signal which are to be multiplexed may come from digital data sources or from analog sources that have been digitally coded, and the digital multiplexer is used to merge the input bits from different sources to form one signal from transmission via a digital communication system. The multiplex signal consists of source digit interleaved bit by bit or word by word. Let's see the importance function of digital multiplexer. The important function that must be performed by a multiplexer are as under: to establish a frame. A frame consists of at least one bit from every input, and a number of unique bit slots within the frame should be assigned to each input, and to insert control bits for frame identification and synchronization, and to make allowance for any variations of the input bit rates. Next, we see the classification of digital multiplexing. The various digital sources that are to be multiplexed will have different bit rates. In practice, the bit rate variation poses the most serious design problem and lead to the three categories of multiplexer as under. The first type is synchronous multiplexer, the second one is asynchronous multiplexer, and third one is quasi-synchronous multiplexer. So the synchronous multiplexer is: in the synchronous digital multiplexers, the master clock governs all the sources. Therefore, all the sources will operate at the same bit rate. As the bit rate variations are completely eliminated, the synchronous multiplexing system attain a very high throughput efficiency, but they need elaborate provisions to distribute the master clock signal to all the sources. And in asynchronous multiplexer, the asynchronous multiplexers are used for the digital data sources which operate in the start or stop mode. These sources produce a data in the form of bursts of character with a variable spacing between bursts, and the techniques such as buffering and character interleaving makes it possible to merge the source into the synchronous multiplex bit stream. And third one is quasi-synchronous multiplexer. The multiplexer are used when the input bit rates have the same nominal value but vary within a specific bounds. These multiplexers are arranged in a hierarchy of increasing bit rates to constitute the basic building blocks of an interconnected digital telecommunication system. So this is all about the introduction to digital multiplexer. Thank you everyone.